Hi, everyone. Thanks for joining today. My name is Hannah Brackey, and I'm really excited to walk you through how LabKey LIMS can support metallurgy teams in managing their data more efficiently. And so in mining, the journey from pit to plant is often very data intensive. Every assay, every sample, every test can contribute to decision making, but often that information can be really scattered. Spreadsheets here, paper notebooks there, instruments generating files that don't always fit together really neatly. And so our goal with this session is to show you how LabKey helps connect all those different dots, giving you that traceability and insights from the moment a sample comes out of the ground until all the way through processing. So a couple of quick housekeeping notes before we get started. The session is being recorded, and so a link to the recording will be sent to anybody that's registered. So if you're not able to stay the whole time, or if you want to share this with colleagues, that's going to be available to you after the webinar. And then please feel free to drop any questions either in the Q&A or the chat as we go. I'll try and sort of keep track of those and answer during the session, or definitely we're going to leave some time after the session as well. So first, a quick word about who we are. LabKey has been around for over 20 years, supporting data management in a variety of different scientific disciplines, including mining and metallurgy. Our software is flexible and intuitively designed to help ensure the system matches your lab and is easy for scientists of all kinds to use. And what really makes LabKey different is that we're not just a software vendor, we see ourselves as a partner in science. That means we spend the time to understand how your lab works, help configure workflows to fit your reality, and support you all the way through adoption and maintenance of the software. So let's talk specifically about metallurgy teams. And you all deal with really high sample throughput, so hundreds or even thousands of samples a week. Manual data entry can really contribute to delays and errors, which slows down decision making, which we know is very vital to the business. Many of you are also running multi-step procedures, drilling, crushing, splitting, digestion, ICP-MS, the whole chain of steps. And so without standardization, those workflows can become inconsistent and data can get really fragmented over time. And then finally, there's critical assay results. So if that data goes missing or if the chain of custody isn't clear, confidence in the results suffers. And that can really have serious downstream impacts. And so that's where a LIMS can step in to streamline that data capture, ensure traceability, and standardize those workflows so your data is reliable and accessible. So how does LabKey address those challenges specifically? We provide flexible sample and storage management, so you can define custom sample types, drill cores, pulps, composition, whatever fits your process, and we'll see that today in the demo, and track them across that full life cycle in the lab. There's also standardized workflows and a connected ELN. And so templates and linked lab notebook entries can ensure procedures are consistent. And you can capture all those steps in like sample prep or pulverization and tie those directly to your data. The third point here is around integrated assay data management and reporting. And so instead of manually moving these files around, LabKey can ingest instrument outputs and harmonize them with the sample metadata within the system. And that really gives you a built-in connection between those assay results and the samples, as well as providing visualizations so you can see any trends in real time. And at the end of the day, it's really about sort of centralizing everything, samples, workflows, results, reports, all in one connected system. So let's make this a little bit more concrete with an example. So if we can imagine a typical drill core sample making its way through the lab, you start with collection and logging, and then you move through drying, crushing, and splitting, pulverizing. And from there, you might aliquot pulp samples for acid digestion, run an ICP-MS, or prepare composites. And so that ends up being a lot of moving parts. And if any step is sort of missed or misrecorded, you might lose confidence in those results. And so with LabKey, you can use those workflows to capture those high-level tasks consistently every time. You can also track that sample lineage and location. So from that original core down to sort of the smallest aliquot that you create in the lab. We can also capture that ICP-MS and mass result directly without sort of that manual entry or manipulation that may happen. And then finally, centralize that experiment summary in the ELN so both metallurgists and managers have one clear picture. And this way, whether you're deep sort of in that technical area or making strategic decisions at the leadership level, you're working from a single reliable source of truth. And so now that you've seen kind of the big picture of LIMS and LabKey LIMS, let's jump into this demo. And so I'll show you here how LabKey actually manages drill core sample from intake all the way through that ICP-MS result capture. So you can see sort of firsthand how our system handles both the details as well as sort of that bigger workflow. So I think here, perfect. Just move stuff around. So now you can see when I log in, we have our main dashboard, and this is really providing high-level insights to what our sample composition looks like within the lab, allows me to see any active work that I have on my plate or within the lab in general, as well as any notebooks that I'm working on or things that need reference. So this isn't a static view. It really provides kind of that operational visibility into what's happening. And if something is sort of backing up in one of those processes, you're going to be able to see this here immediately. We're a very sample-centric system. So the samples here have different statuses based on where they're at in the process. And this allows you to also sort of trace everything within the lab as well. So to get our bearings here, I'm going to open up our menu, and that really gives us kind of an insight into the data within the system. We have our source types, which are metadata about samples. So here we have metadata about mines, maybe the location, as well as the drill holes. And so we can get more specific into where those drill holes were collected, as well as the different samples that we're working with. And so we've got drill core, composite pulp, digestate, and leach residue. All of these things I have configured and decided as an administrator. And so if the language in this demo doesn't quite match what you guys are collecting in your lab, you're always able to be empowered to change that. We also are capturing a variety of different assays within this lab to test the drill core samples that we're receiving. We've got our storage set up so we know where everything is, if there's long-term or short-term storage needs. We've got our workflow as well as our pick lists. The workflow is a automated system that allows us to execute work within our lab. And we'll see that today. Pick lists are kind of a lightweight way to choose samples and share those with coworkers to use within the system. And then lastly, we have our electronic lab notebook, which allows for the unstructured experiment capture or relationships within the system. So I'm going to go into our drill core sample type. And firstly, you can see that we have a variety of different metadata here that we're capturing on these drill core samples. Again, I've configured this for what this fake LabKey lab needs. This would be something you can control. I can drill into one of these and see more information about this drill core sample, most importantly, that lineage. And so here I'm able to see where this drill core sample came from which hole, from what mine, what composites or aliquots or pulp or ICP samples have been taken from it. I can also see what assay data specifically for the sample we have collected, as well as any workflow jobs that the sample has been part of. And lastly, We've got our sample timeline, which gives a chain of custody, full robust auditing of everything that's happened to this sample since it's been registered in the system. We get an idea of who did it and when, and if there was an update, what that update was. So I'm actually going to go into our workflow jobs, and I can see what jobs are in my queue. And so I'm going to go to my lab meeting demo. And note here, this should look really familiar. We have steps and tasks that have been set up to basically mimic that process that I showed before we jumped into the demo. So we're registering these samples, we're capturing the mass, drying and crushing them, again, sort of registering the mass of those new samples, going through these processes, capturing these assay results, and then finally ending at that ICP. The other part of this workflow job that we can look at is that it's part of a template here. And so this is a template, again, I configured as an administrator that allows me to set what these steps are within my lab. We also have additional metadata that we're capturing within these job details, such as a billing code. I can see what assay results are here, and I can actually go over and look at these assay results in more detail and allow myself to analyze or take a look at these assays as well. So we're going to look at this element by drill hole and the recovery percentage versus concentration, which here is not present. We'll look at one more here. There we go. And for each of these assays, this is just the assay results from our workflow job. I'm able to go into assays overall to be able to compare these ICP-MS assays across runs that I've done to be able to look for trends in different runs of the assay that we've been. And so this is all of our data collated. Again, with any of these grids, I can sort and filter, and all of this is defined by me in terms of what the detection limit is, what fields that we're sort of capturing in each of these components. Go back to our workflow job. Within our workflow job, we can also see the samples that have been either inputs or outputs of the workflow job. So we've got our original sort of drill core samples, as well as our composites, pulp, and digestates. And at each of these levels, we can go in and see sort of the specific metadata that we have captured around these samples. We can make changes here. We can visualize if we wanted to, or export if we needed to provide this to a customer downstream. So the next thing we'll look at is sort of all of the jobs in my lab here. Because this is a fake lab, we don't have a lot of work ongoing, but we're able to look at all of the historical work that has been executed and understand where things are at this stage. So right now, all of the work that we have is in progress. We can see who's been assigned to it, as well as who's currently sort of responsible for making sure that this is getting executed, where the tasks are. So if we're nearly finished or still have a lot of work to do, as well as any of the samples that are included here. If we go back to my lab meeting demo, I'm going to click on my ELN here. And this is our electronic laboratory notebook, which allows us to track sort of the prose that people would be writing traditionally on paper, or maybe more recently in Microsoft Word or other tools. This really has a full data connected electronic laboratory notebook that allows people to track the work that they're executing. And so we also have the information here around the different samples that we've collected. Each of these blue chips are direct references to data within the system. And so we can actually click on one of these and open it. We can see high-level details about these samples as we're going through. We can also reference results and insert images if we need to, or additional attachments on to the notebook for reference. When this experiment is executed, I can then submit this for review and get a sign-off that will snapshot this data in time and create a PDF that allows us to export and share as well. So the last thing I want to show today is really around sort of our source type. So I'm going to go to our drill holes, which allows us to see all the different drill holes that we've captured, as well as what mine it's from. So we've set up the coordinates here with some additional metadata and information about the collection of these drill holes. And for each of these sources, I can actually select one of these and see all of the samples that we've generated from a specific drill hole. So this gives me kind of a quick overview. If I'm a more visual person, I can actually look at this lineage in a graphical form. This is interactive, so I can actually go down and interrogate the composite if something's wrong with this data and go from there. And then similarly to the sample view, I can see the assays that have been generated based on this drill hole, as well as any of the workflow jobs from the samples generated. And so here we can see kind of a quick view of what our ICP results have been for this drill hole. Again, any of our grids can be exported and shared. And so this would be a quick way to share with a client. As I'm using the system, I can find samples in a lot of different ways. I can use our global search, which is going to be the most broad. I can enter in barcodes or sample IDs for samples that I'm using. Or if I'm doing a much more meta-analysis, I can also use our sample finder, which would allow me to say, I'm looking for samples maybe from a specific mine or drill hole, and maybe there's some difference in the geologist that I'm looking for. So I can actually say, well, show me everything that Harrison here has collected, and then I can dig, filter down or dig more into these samples to get sort of the short list of samples that I'm looking for. Okay. And with that, I think we'll kind of wrap up here. If this looked interesting for your team and you're wanting to learn more, one of the things that LabKey does really well is provide these guided evaluations. And how this typically works is having a discovery phase where we're going to work with you to learn your unique processes and requirements. Usually this is just over a single meeting. And then we work with you to configure a custom built demo. And so that demo is really based on the needs of your lab, based on that discovery phase. And then we iterate and work with you to refine that further. And then lastly, we provide you with a free hands-on trial of this demo. And so you're able to test out the system with you and your team and really get a feel for how this is going to work in your environment. And so if this resonates with your lab challenges, please keep an eye out for a follow-up email to schedule a guided session. And if there's any questions, feel free to put them in the Q&A or the chat, and I'll answer them. Yeah, so one of the questions that we get often is around implementation timing. And so typically this implementation takes about 6 to 10 weeks, really depending on kind of the configuration of your system. But we're really talking about days and weeks and not months and years, which is very typical for a more historic or legacy LIMS system. Other questions? Yeah, so somebody asked about kind of automated instrument integration. And so the assay, the ICP-MS assay that we use kind of as the the tools here within the demo is a great example of, the instrument is generating a file that might not be the most friendly for a tabular database. And so the transformation script can actually ingest that raw instrument file and transform it into the format that you want, providing calculations and things like that. And that's something, again, that LabKey will sort of fully support and help you with. Okay. Any other questions? I'll leave you with just keep an eye out for the incoming emails. You're going to get the recording after this, as I mentioned at the beginning of the demo, as well as if you'd like to schedule some time to chat with me or my colleagues about doing a guided evaluation, happy to help with that as well.